Good day everyone, I am Aryan Grace Ebale from BSIE1 BGL and today I will solve this problem. A trough of water is 8 meters in length and its ends are in the shape of isosceles triangles whose width is 5 meters and height is 2 meters. If water is being pumped in at a constant rate of 6 cubic meter per second, at what rate is the height of the water changing when the water has a height of 120 centimeter? At what rate is the width of the water changing when the water has a height of 120 centimeter? We have a trough of water that is 8 meters in length, so this is going to be 8 meters down here. The ends of the trough are isosceles triangles, and we know that isosceles triangle is a triangle which two sides are the same length. In this example, the sides of the tank have the same length. The width of the triangles is 5 meters, so this is 5 meters here, and it's going to be the same over here, and the height is 2 meters. So, we have all of that, and it says that water is being pumped in at a constant rate of 6 cubic meters per second. So, that's how the volume of the water is changing. So, I'm going to say B prime is equal to 6 cubic meters per second. We want to know H prime when H is equal to 120 centimeter. Now, it's going to be a good idea to write that into meters. So, that's going to be 1.2 meters. The reason to do that is all the other measurements are measured in meters. The formula for the volume of this trough, we're going to say that the volume is just the area of this end piece, which is a triangle. Then multiply by the depth. So it is 1/2 base times height times by whatever the depth or length is. So cleaning that up a little, we're going to have V is equal to 1/2 the base times the height, and our depth or length is 8. So our volume is equal to 4 times the base times the height. I use width because that is what this problem is using, so we will use the same variables here. So 4 times height times the width gives us the volume. So we've got an extra quantity here, which is the W or the width, that is also changing with time, so we need to eliminate it from the problem. To do this, we will make use of the idea of similar triangles. If we look at the end of the tank, we'll see that we again have two similar triangles. One for the tank itself, which is this, and one formed by the water in the tank, which is this. Again, remember that with similar triangles, ratios of sides must be equal, so we will use W over 5 is equal to H over 2. So the proportion we can say is the ratio of the width here is going to be 5 to 2 times the height. Plugging this into the volume gives a formula for the volume and only for this tank that only involve the height of the water. Volume is equal to 4 times height times width. So that is equal to 4 times the height times the value of the width, which is 5/2 height, which is equals to 10h squared. We can now differentiate it with respect to t, and I'm going to get B prime is equal to 20h times h prime. Finally, all we need to do is plug in and solve for h prime. So we have B prime that was given to us, which is 6 equal to 20, which is the B prime, and 1.2, which is the height, times h prime. 6 equals the product of 20 and 1.2 is equals to 24 times h prime. To solve for the h prime, we need to divide both sides by 24. So 6 divided by 24 is equals to 0.25. So the height of the water is rising at a rate of 0.25 meter per second. In order to answer the second part of this question, we will need W prime to answer this part. And we have the following equation from the similar triangle that relate the width to the height, and we can quickly differentiate it to get a relationship between W prime and H prime. Width equals 5/2 times height. So, we need to differentiate it with respect to t. So, we will get W prime is equal to 5 halves times h prime. From the first part, we already know the value of h prime, and so all we need to do is plug that into this equation and we will have the answer. So, w prime is equal to 5 halves multiplied by 0.25, which is the h prime. 5 halves multiplied by 0.25 is equal to 0.625. Therefore, the width is increasing at a rate of 0.625 meter per second. Next, we're going to solve for problem number 6. A light is on the top of a 12 feet tall pole and a 5 feet 6 inches tall person is walking away from the pole at a rate of 2 feet per second. Question A. At what rate is the tip of the shadow moving away from the pole when the person is 25 feet from the pole? Question B. At what rate is the tip of the shadow moving away from the person when the person is 25 feet from the pole? So let's start off with putting all the relevant quantities into the sketch. Here, x is the distance of the tip of the shadow from the pole. X sub p is the distance of the person from the pole. X sub s is the length of the shadow. Also, note that we converted the person's height over to 5.5 feet since all the other measurements are in feet. The tip of the shadow is defined by the rays of light just getting past the person, and so we can see they form a set of similar triangles. This will be useful down the road. The rate of the person walking away from the pole is 2 feet per second, and that is the value of x prime sub p. In this case, we want to determine x prime when x sub p is equal to 25, given that x prime sub p is equal to 2. The equation we will need here is x equals x sub p plus x sub s. But we will need to eliminate x sub s from the equation in order to get an answer. To do this, we can again make use of the fact that the two triangles are similar to get 5.5 over 12 equals x sub s over x. Note that 5.5 over 12, the fraction form of 5.5 is 11 halves, then over 12. So that is equals to 11 over 24. From this, we can quickly see that x sub s is equals to 11 over 24x. Then, we can plug this into the equation above and solve for x as follows. X equals x sub p plus x sub s equals x sub p plus 11 over 24x. Using similar triangles, we can say that 12 over x is equals to 5.5 over x minus x sub p. Cross multiplying, we get 12x minus x sub p equals 5.5x. Then distribute 12x minus 12x sub p equals 5.5x. Then we need to transpose 5.5x. So that will be 12x sub p minus 5.5x is equals to 12x sub p. 12 minus 5.5 is equal to 6.5. Then equals to 12x sub p. Then divide both sides by 6.5 to get the x. X equals 12 over 6.5 x sub p. Press 12 over 6.5 in the calculator. Then we will get the value of 24 over 13. Now, all that we need to do is to differentiate this. So we're going to find the derivatives of x equals 24 over 13 x sub p with respect to t. So that is x prime is equals to 24 over 13 x prime sub p. To solve for x prime, we need to plug in the value of x prime sub p, which is 2. (24 over 13 times 2 is equals to 48 over 13. X prime is equals to 48 divided by 13 is equals to 3.6923 feet per second. The tip of the shadow is then moving away from the pole at a rate of 3.6923 feet per second. Notice as well that we never actually had to use the fact that x sub p is equals to 25 for this problem. That will happen on rare occasions. The next question is at what rate is the tip of the shadow moving away from the person when the person is 25 feet from the pole? In this case, we know that x sub s represents the length of the shadow, or the distance of the tip of the shadow from the person. So it looks like we want to determine x prime sub s when x sub p is equals to 25. Again, we can use x equals x sub p plus x sub s. However, unlike the first part, we now know that x prime sub p is equals to 2 and x prime is equals to 3.6923 feet per second. So in this case, all we need to do is differentiate the equation and plug in for all the known quantities. Then we're going to find the derivatives of x equals x sub p plus x sub s with respect to t. So that is x prime is equals to x prime sub p plus x prime sub s. Then we will now plug in all the known quantities. X prime is equals to 3.6923, x prime sub p is equals to 2, plus x prime sub s. To get the value of x prime sub s, we need to transpose 2. So that will be negative 2 plus 3.6923 is equals to x prime sub s. Negative 2 plus 3.6923 is equals to 1.6923. So, x prime sub s is equals to 1.6923 feet per second. Finally, the tip of the shadow is then moving away from the person at a rate of 1.6923 feet per second.
Exercise 7. A spotlight is on the ground 20 feet away from a wall, and a 6 feet tall person is walking towards the wall at a rate of 2.5 feet per second. How fast is the height of the shadow changing when the person is 8 feet from the wall? Is the shadow increasing or decreasing in height at this time? Ito yung wall. And ito yung distance between the wall and the spotlight. This is the spotlight. And ito yung person. And this is the shadow behind the person. Yung wall ang magiging y natin, and at habang yung distance between the wall and the spotlight ang magiging x. And we all know that ang value ng x natin is 20. Ang ating dx over dt ay 2.5 feet per second at ang hinahanap naman natin dito ay yung dy over dt. So we have here now a sketch of a triangle with all the given in the problem. The top of the shadow will be defined by the light rays going over the head of the person. So we got here a set of similar triangle. In this problem, we are looking for the dy over dt when the person is 8 feet from the wall, or x is equals to 12 feet. So, since lumalapit yung tao papunta dun sa wall sa bilis na 2.5 feet per second, ibig sabihin, lumalayo siya dun sa spotlight sa bilis din na 2.5 feet per second. And base sa problem, we know that ang dx over dt natin dito ay 2.5 feet per second. Dito, pwede tayong gumamit ng equation that relates x and y directly from the two similar triangles. So, ang gagamitin natin na equation ay ito. Y over 6 equals 20 over x. Dito natin makukuha yung dy over dt is equals to 120 over x. And now, ang gagawin na lang natin ay to differentiate and plug values into solve para makuha yung dy over dt. dy over dt equals to negative 120 over x squared multiplied by dx over dt. Now, let's substitute our given. Negative 120 over 12 squared multiplied by 2.5 is equals to negative 2.0833 feet per second. Now, therefore, the height of the shadow is then decreasing at a rate of 2.0833 feet per second. Example 8. Two people on bikes are separated by 350 meters. Person A starts riding north at a rate of 5 meters per second, and 7 minutes later, person B starts riding south at 3 meters per second. At what rate is the distance separating the two people changing 25 minutes after person A starts riding? This is the 350 meter distance between the person A and the person B. Ito yung person B at ito yung person A. Yung person A or yung biker A, lumiko siya papuntang north at a rate of 5 meter per second. At ito yung magiging dx over dt natin. Habang itong person B or yung biker B, lumiko siya sa south at a rate of 3 meter per second. And ito yung magiging dy over dt natin. And dahil meron na tayong dx over dt and dy over dt, ang hanapin naman natin ngayon is yung dz over dt. We want to know dz over dt after person A had been riding for 25 minutes and person B has been riding for 18 minutes. 18 minutes because 25 minutes minus 7 minutes equals 18 minutes. Ngayon, i-convert natin sa seconds yung time na meron tayo kasi Ang rate sa ating problem, sa ating given problem, are all in meter per seconds. X equals 5 times 25 times 60 is equals to 7,500 meter. And then Y equals 3 times 18 times 60 is equals to 3,240 meter. At ngayon, gagamit naman tayo ng Pythagorean theorem. Z squared equals to x plus y squared plus 350 squared. And now, i-substitute naman natin yung mga given na nakuha natin kanina doon sa formula ng Pythagorean theorem. So, z is equals to square root of x plus y squared plus 350 squared. Now, let's substitute. C is equals to square root of 7,500 plus 3,240 squared plus 350 squared. And makukuha natin yung sagot na 10,745.7015 meter. Therefore, 25 minutes after person A starts riding, the two bike riders are 10,745.7015 meter apart. To determine the rate at which the two riders are moving apart, all we need to do then is differentiate 2 and plug in all the quantities that we know to find the dz over dt. So, 2z dz over dt is equals to 2 multiplied by x plus y multiplied by dx over dt plus dy over dt. Ngayon, i-substitute na natin yung mga given natin dun sa formula. 2 multiplied by 10,745.7015 and dc over dt equals to 2 multiplied by 7,500 plus 3,240 multiplied by 5 plus 3. Therefore, our dc over dt is 7.9958 meter per second. So, the two riders are moving apart at a rate of 7.9958 meter per second.